Periodic classification of elements. In this lecture, we will be learning about the classification of elements in a periodic fashion and the need for classification. Coming to the introductory part, actually in the early ages, slowly as time passed away, more and more elements were founded, and scientists then found it very difficult to recognize each of these elements. Then actually came the idea of classifying these elements. The first classification ever was done by Dobereiner, a German scientist, actually a chemist. Coming to Dobereiner's trade. So Dobereiner was a German chemist, and what he actually did was he classified the elements into a group of 3 elements on basis of similarity of properties. These groups were called as a trade. Characteristics of the Dobereiner's trade. The property of the elements in each trade were similar. The atomic mass of the middle element was roughly the average of the atomic mass of the other 2 elements. An example of a Dobereiner's trade. Some of the popular examples are listed below. In each of the 3 trades, we can see that the atomic mass of the middle element is the average of the sum of the 2. Limitations of the Dobereiner's trades. Dobereiner could not identify more than 3 trades. He wasn't able to prepare the trades of all the known elements. That was the main drawback. Then the next classification of elements was done by an English scientist known as John Newland. Newland's law of octaves. John Newlands, an English scientist, has arranged the known elements in the order of increasing atomic masses, and he named it as the law of octaves. It is known as the Newlands law of octaves. This was completely analogous to the octave in the music, sa re ga ma pa da ni, which is 1 octave. Coming to the characteristics of the Newlands law of octaves, it contained the elements from hydrogen to thorium. The property of every 8th element was similar to that of the first element. Now let's have a look at the Newlands octaves. Now, coming to the limitations of Newland's laws of octaves. This law was applicable only to elements up to calcium, not beyond calcium. It contained only 56 elements. Further, it was assumed that only 56 elements existed in the nature and no more elements could be discovered in the future. In order to fit these elements into the table, some of the elements were paired up as shown in the table before. For example, cobalt and nickel were in the same slot, and similarly chlorine and bromine, even though they had different properties, were paired up together. Iron, which resembles cobalt and nickel in properties has been placed differently from these elements. These were the main drawbacks of this model. After these two unsuccessful attempts of classification, a new attempt of classification was made by Mr. Mendeleev, which was a breakthrough in the classification of elements. Coming to Mendeleev's periodic table. Mendeleev was the most important contributor to the early development of a periodic table of elements. Here the elements were arranged as the basis of their atomic mass and chemical properties. Characteristics of Mendeleev's periodic table. Mendeleev arranged all the 63 elements known then in the increasing order of atomic masses. This table contained vertical columns known as groups and horizontal rows called as periods. The element with similar physical and chemical properties come under the same group. Mendeleev's periodic law. The properties of elements are the periodic function of their atomic masses was Mendeleev's periodic law. Now let us have a look of the Mendeleev's periodic table. This is just to get an idea. You need not remember it. Now what are the achievements of the Mendeleev's periodic table? Through this table it was very easy to study the physical and chemical properties of various elements. Mendeleev adjusted few elements with slightly greater atomic mass before the elements with slightly lower atomic mass so that the elements with the similar properties could be grouped up together. For example, aluminium appeared before silicon, cobalt appeared before nickel, which wasn't in a proper order of atomic mass. Mendeleev left some gaps in his periodic table. He predicted the existence of some elements which hasn't been discovered at his time. His predictions are actually quite true. For example, like scandium, gallium and germanium, which he predicted were actually discovered later. Gases like helium, neon and argon, which were discovered later, were placed in a new group without disturbing the existing order. Now let us know about the limitations of the Mendeleev's periodic table. He could not assign a correct position to hydrogen in the periodic table. Positions of isotopes of all elements was not certain according to Mendeleev's periodic table. Atomic mass did not increase in a regular manner in going from one element to the next. So it wasn't possible to predict how many elements could be discovered between two elements. These were the main drawbacks of this model of classification. Keeping all these limitations in mind, a scientist named Henry Moseley has come forward with a new classification, and he named this classified table of elements as the modern periodic table. Now let us study about this modern periodic table. Coming to the modern periodic table, in this periodic table, the elements were classified as a function of their atomic number. The modern periodic law states that the properties of the elements are a periodic function of their atomic number. Now let us have a look at the modern periodic table. This is just to get an idea. You need not remember again. These horizontal rows are known as periods, and these vertical columns are all called as groups. Now let us learn about the position of elements in the modern periodic table. The modern periodic table consisted of 18 groups and 7 periods. The elements present in any one group will have the same number of valence electrons. Also, the number of shells increases as we go down the group. Elements present in any one period contain the same number of shells. Also, with the increase in atomic number by 1 unit on moving from left to right, the valence shell electron increases by 1 unit. Each period marks a new electronic shell getting filled. Now let us observe the various trends in this modern periodic table. Starting with valency. Valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. Right? Valency of an element in a particular group will be the same. Valency of an element in a particular period will increase by 1 unit from left to right with the increase in atomic number by 1 unit. Now coming to the atomic size. Atomic size refers to the radius of an atom. In a period, the atomic size and the radii decrease from left to right. This is because there is an increase in nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom. In a group, the atomic size and radii increases from top to bottom because as we go down, a new shell gets added up, which increases the distance between the outermost electrons and the nucleus, and hence increases the size of the atom. The third one would be metallic and non-metallic properties. The tendency to lose electrons from the outermost shell of an atom is called the metallic character of an element. Metallic character decreases across a period and increases down the group. The tendency to gain electron in the outermost shell of an atom is called non-metallic character of an element. The non-metallic character increases across a period and decreases down the group, which is just opposite to the metallic character. Elements having intermediate properties of the metal and a non-metal are known as metalloids. Metals generally have a tendency to lose electrons while forming a bond, hence they are electropositive in nature. On the other hand, nonmetals have a tendency to gain electrons while forming a bond, hence they are electronegative in nature. Oxides formed by metal are generally basic, and oxides formed by the nonmetals are usually acidic in nature. The end. Thank you for watching.